A matrix A is said to be an invertible matrix if and only if it is a non-singular matrix. Non-singular matrix means determinant of A is not equal to 0. What is A inverse? As usual, you know, A inverse is equal to 1 over determinant of A into adjoint of A. If determinant of A is not equal to 0, then it is called a non-singular matrix. Inverse exists if and only if determinant A is not equal to 0. That is a non-singular matrix. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important problems for 5 marks, that is solving a system of linear equation using matrix method, a 5-marker question. Now let me come to the concept. Now a matrix A is said to be an invertible matrix if and only if it is a non-singular matrix. Non-singular matrix means determinant of A is not equal to 0. If determinant of A is not equal to 0, then it is called a non-singular matrix. Inverse exists if and only if determinant A is not equal to 0. That is a non-singular matrix. A square matrix A is invertible if and only if A is a non-singular matrix, and the inverse of the matrix is denoted as A inverse. This is called the inverse. And the inverse of a matrix is given by A inverse is equal to 1 over determinant of A into adjoint of A, or A inverse is equal to adjoint of A divided by determinant A is called the inverse of a matrix. So, A inverse is equal to adjoint of A divided by determinant A. Now, let me take an example. So, let us take an example. Find the inverse of a matrix A is equal to. So, for this matrix, just find out the determinant of A. Check whether it is a singular or non-singular matrix. Determinant of A is equal to determinant 3, 2, 1, minus 1. So, the values minus 1 into 3 is minus 3, 2 into 1 is minus 2, this is equal to minus 5. Determinant of A is equal to minus 5, not equal to 0. So, A inverse exists. A inverse exists. And A inverse is given by A inverse is equal to adjoint of A divided by determinant of A. Find out the adjoint of A. The adjoint of this matrix is given by, as I explained in the previous class itself, you know, for a 2 rows 2 column, the adjoint can be easily determined by interchanging the diagonal elements. So 3 minus 1 can run as minus 1 and 3, and changing the signs for the secondary diagonal elements. This is minus 2 and minus 1. So, that is minus 1, minus 2, minus 1 and 3 is the adjoint of this. So, therefore, A inverse is equal to 1 over determinant of A into adjoint of A, that is 1 over. What is determinant of A? That is 5, minus 1 over 5 into minus 1, 1, minus 2 and 3 is the inverse for the given matrix. So, A inverse is equal to minus 1 over 5 times minus 1, minus 2, 1, 3 is the inverse of a matrix. Now, so in case of 3 rows 3 column, just find out the cofactors for each and every elements, and then adjoint is equal to the transpose of the cofactor matrix. Now, this is very important concept. Using this concept, we are going to solve the simultaneous equations. So, that is one of the applications of determinant. To solve the system of equations using matrix method, we are going to use the concept of A inverse. Now, straight away come to the system of equations by matrix method. How to find the solution for the system of equations using matrix method is very important, a sure question for 5 marks. Let us discuss 2 or 3 marker question first. Solve the system of equations 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7 using matrix method. What is the equation given here? 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7. First write down A. What is A? A is equal to the coefficient of x and y. This is 2, 5. Here it is 3 and 2. So, 2, 5, 3, 2 coefficient of x, y. Now, what is x here? X is nothing but the matrix x and y. Then, matrix B. B is equal to the constant 1 and 7. The solution is given by, therefore, the solution for this is given by, the solution is x is equal to A inverse into B. A inverse B is the solution. Now, what is A inverse? As usual, you know, A inverse is equal to 1 over determinant of A into adjoint of A. Now, first find out determinant of A. Determinant of A is equal to determinant 2, 5, 3, 2. Its value 2 to the 4 minus 5 3 is 15. This is equal to minus 11. Not equal to 0. So A inverse exists. Right. Here, first write down the values of A, B and X. A is coefficient of X, Y, X, Y, 2, 5, 3, 2 and X and Y is as it is, and B is nothing but the constant 1 and 7. Find out the determinant of A. Determinant of this is 2 to the 4 minus 5 3 is 15 is minus 11. A inverse is equal to 1 over determinant of A into adjoint of A. Now find out the adjoint for this. Now as I told in the previous problem itself, the adjoint of A is equal to, straight away we can write adjoint of A is equal to, interchanging the diagonals 2 and 2 as it is, there is no change, 2 and 2 remains the same, and changing the signs for the secondary diagonal elements, that is 2 minus 5 minus 3 2 is the adjoint. So therefore A inverse is equal to 1 over determinant A. What is determinant A? Minus 11 into adjoint of A, 2 minus 5 minus 3 and 2. So therefore X is equal to A inverse into B, that is X and Y is equal to A inverse minus 1 over 11 into A minus 2 minus 5 minus 3 2 into B matrix. What is matrix B? B is equal to 1 and 7. Simplify this. That's it. Now if I simplify this, that is X and Y is equal to minus 1 over 11 into, just multiply first row, first column, 2 1s are 2, again 7 5s are 35, again minus 3 1s are 3, plus 2 7s are 14. This is equal to minus 1 over 11 into 2 minus 35. 2 minus 35 is minus 33 and 14 minus 3 is equal to 11. So if you divide by minus 11, minus and minus gets cancelled, 33 by 11 is 3 and 11 by 11 is 1, that is along with negative sign. So therefore here x comma y is equal to 3 and minus 1, therefore x is equal to 3 and y is equal to minus 1. That's it. This is how we are going to solve a simultaneous equation using matrix method. That's it. Right, very simple problem. Now, if you want to verify, you can verify, just substitute the value of x and y here. X is equal to 2 and y is equal to minus 1. 2 3s are 6, plus 5 into minus 1 is minus 5. 6 minus 5 is equal to 1. That's it. Now, move on to the next problem. Now, this is very important type problem for 5 marks. Now, it's a 5 marker question. Solve the system of equation 3x minus 2y plus 3z is equal to 8, 2x plus y minus z is equal to 1 and 4x minus 3y plus 2z is equal to 4 using matrix method. These type of problems are very important. This is a sure question for 5 marks. Now, check whether it is in order or not. X, Y, Z, X, Y, Z, X, Y, Z and constant. Now, write down A here. A is equal to the coefficient of x, y, z 3, minus 2 and 3. For the second matrix 2, 1, minus 1. For the third equation, the coefficient of x is 4, y is minus 3, z is equal to 2. This is matrix A. 3, 2, 1, minus 1, 4, minus, and then matrix B is equal to constant. What are the constant elements? 8, 1 and 4. Then x is equal to, the variables are x, y and z. Therefore, what is the solution? The solution is x is equal to A inverse into B. What is A inverse? A inverse is equal to 1 over determinant of A into adjoint of B. That's it. Right. So, if you write this much, then you will have an idea how to solve. Now, first find out the determinant of A. Determinant of A is equal to determinant 3 minus 2, 3, then 2, 1, minus 1, 4, minus 3 and 2. Simplify this, plus, minus and plus. So, that's equal to 3 into 1 2s are 2, plus into minus, minus 3 1s are 3, minus into minus plus 2 into, this row and column is gone, 2 2s are 4, minus into minus plus 4, plus 3 into, this row and column is deleted, 2 into 3 is minus 6, minus 4. This is equal to 3 into minus 1, plus 2 into 8, plus 3 into minus 10, minus 3, 8, this is 8, 8 2s are 16, this is 10, 10 into 3. 10 into 3 is equal to 30. Now, what is this equal to? 16 minus 30 minus 3 is minus 33. That's equal to minus 17. So, therefore, determinant of A is equal to minus 17, not equal to 0, A inverse exists. So, determinant of A is equal to minus 70. So, here determinant of A is equal to minus 70, not equal to 0, therefore, A inverse exists. Now, find out the cofactors for each and every element for this. Now, what is A? A is equal to determinant 3, 2, 4, then minus 2, 1, minus 3, minus 2, 1 and minus 3, 3, minus 1, 2, 3, minus 1 and 2. This is the matrix determinant. Now, signs, what are the signs? Plus, minus, plus, minus, plus, minus, plus, minus and plus. The signs or diagonals are positive. Just go on writing the cofactors. Now, let us call it as A11 is equal to cofactor of first element 3. So, just delete this row and column 1, minus 1, minus 3 and 2. This is equal to 1, 2 is 2, minus into minus, plus into minus, minus, that is equal to minus 1. 2 minus 3 is minus 1. Similarly, cofactor of minus 2. What is the sign? Negative. This is gone. This row column is deleted. 2, minus 1, 4 and 2. So, 2, 2, this is minus out. 2, 2 is 4. Minus into minus plus. 4 plus 4 is 8 along with negative sign. Similarly, cofactor for the next element 3 is equal to, this row and column is gone, that is 2, 1, 4, minus 3. That is equal to 2 into 3 is minus 6, minus 4, that is equal to minus 10. Minus 1, minus 8, minus 10 is a cofactor for the first row. Let me go for the second row. Cofactor of 2 is equal to, what is the sign? It is minus. Straight away I will do. This row and column is gone. Minus 2 into 2 is minus 2 into 2 is minus 4, minus into minus plus 3, 3 is 9. So, 9 minus 5 is 4 along with negative sign, minus 5. Similarly, cofactor for 1 is equal to, this row and column is gone, this row and column, 3 2s are 6, 6 minus 4 3 is 12. So, that is equal to 6 minus 12 is minus 6. And cofactor for minus 1, it is negative again. So, this row column is gone, 3 3s are 9, minus 9, minus 3 3s are 9 again, 4 into 2, minus into minus plus, 4 2s are 8, that is equal to minus of minus 1 is equal to plus 1. So, the cofactors for the second row is minus 5, minus 6 and plus 1. Find out the cofactors. Similarly, the cofactor of the last row 4 is equal to, this row and column is gone, minus 1 into minus 1 is plus 2, 1 into 3 is 3, that is equal to minus 1. Now, similarly, find out the cofactor for 3. Now, cofactor of minus 3 is equal to, cofactor of minus 3 is negative sign, minus, this row and column is gone, 1 3s are 3, minus 3, 2 3s are 6, minus 3, minus 6. Minus 3 minus 6 is equal to minus of minus 9, minus of minus 9, that is equal to plus 9. And last element, cofactor of, what is the last element? 2. Cofactor of 2 is equal to, this row column is gone, 3 1s are 3 plus 2, minus into minus plus, 3 plus 2 2s are 4, that is equal to 7. So, minus 1, plus 9 and 7 is a cofactor for the last row, right. Now, write down the cofactor matrix. So, therefore, I will go to the next page. Therefore, straight away we can write the adjoint of A is equal to, write down the first column. This is the first column. Instead of writing first row, second row, third row, if you represent these elements in first column, second column, third column, that itself will straight away give the adjoint. So, the adjoint of A is minus 1, minus 8 and 10. Minus 1, minus 8, minus 10, first column. And the second row becomes second column, minus 5, minus 6, plus 1, minus 5, minus 6 and plus 1. And the last row becomes last column, minus 1, 9 and 7, minus 1, 9 and 7. This is the adjoint. Now, therefore, A inverse is equal to 1 over determinant of A into adjoint of A. What is determinant of A? Determinant of A is minus 17. So, minus 1 over 17 into minus 1, minus 8, 10, minus 10, minus 5, minus 6, 1, minus 1, 9 and 7. This is the inverse. So, therefore, the solution is X is equal to A inverse into B. Now, therefore, what is X is equal to A inverse into B? X is nothing but X, Y, Z is equal to minus 1 over 17 into the matrix minus 1, minus 8, minus 10, minus 5, minus 6, 1 and minus 1, 9, 7 into the matrix. What is B? 8, 1, 4. 8, 1 and 4. Simplify this, you will get the answer. That's it. Now, what is this equal to? Minus 1 over 17 into first row, first column. 1 8s are 8, minus 5 1s are 5, minus 1 4s are 4. Again 8 8s are 64, minus into plus it is 6 1s are 6, 9 4s are 36. Again minus 10 into 8 is 80, plus 1 1s are 1, plus 7 4s are 28. This is equal to minus 1 over 17 into minus 5 minus 4 is minus 9, minus 8 is minus 17. Then 36, yes, minus 64 minus 6 is minus 70 plus 36. Minus 70 plus 36 is equal to minus 34. It's minus 34. Then 28 plus 1 is 29. Minus 80 plus 29. Minus 80 plus 29 is equal to minus 51. Now divide each and every element by minus 17. Minus and minus gets cancelled. 17 by 17 is 1. Minus minus gets cancelled. 17 2s are 34. 17 3s are 51. So therefore, the value of x is equal to 1, y is equal to 2 and z is equal to 3. That's it. So if you do this much, definitely you will get 5 marks. This is a sure question. Hope you followed. That's it. Now move on to the similar type problem. If A is equal to 2, minus 3, 5, 3, 2, minus 4, 1, 1, minus 2, a determinant or a matrix, find the inverse. Find the inverse using A inverse, solve the system of equations. See, if you observe carefully, the coefficient of x, y, z is nothing but the given matrix. Coefficient of x is 2, y is minus 3, z is 5 and 3, 2, minus 4 and 1, 1, minus 2. So, if you find the inverse, this is sufficient for you to solve the system of equations. Right. Now, first find out the inverse. Before that, write down the determinant. Determinant of A is equal to 2, minus 3, 5, 3, 2, minus 4, 1, 1, minus 2. So, this is plus, minus and plus. 2 into minus 4, minus into minus plus 4, minus into minus plus 3 into this row and column is gone. 2 3s are 6 plus 4 plus 5 into this row and column is deleted. 3 1s are 3 minus 2. This is 2 into 0 plus 3 into minus 2 plus 5 into 1. This is 0 into 2 is 0. 3 2s are 6 minus 6 plus 5, that's equal to minus 1. Determinant of A is equal to minus 1, not equal to 0. Therefore, A inverse exists. A inverse exists. Now, just find out the cofactors. That's it. Now, what is given? A is equal to determinant 2, 3, 1, then minus 3, 2, 1, then 5 minus 4, 2, 5 minus 4 and minus 2. Now, signs for this is plus, minus, plus, minus, plus, minus, plus, minus and plus. Now, just write down the cofactors. Cofactor of 2. This row and column is gone. 2 2s are 4, minus into minus, plus 4, that is 0. Similarly, cofactor of minus 3 is minus sign. This row and column is gone. 3 2s are 6, minus into minus, plus 4. This is minus of minus 2 is plus 2. And the cofactor of 5 is equal to this row and column is gone. 3 1s are 3, minus 2. That's equal to 1. That's it. 0, 2 and 1 are the cofactors for the first row. Now, similarly, find out the cofactors for the second rows. Now, cofactor of second row. Similarly, second row it is 3. For 3, the sign is minus. This row and column is gone. 3 2s are 6, minus into minus, plus 6, minus 1 5s are 5. That's equal to minus of 1 is minus 1. And similarly, the cofactor for the second element 2 is equal to this row and column is gone. 2 2s are 4, minus 4, minus this 2 2s are 4, minus 1 5s are 5. That's equal to minus 4 minus 5 is minus 9. and cofactor for minus 4, it is negative sign. This row and column is gone. 2 ones are 2 plus 3, 1 3 is 3, 2 plus 3, that's equal to minus. Similarly, for the third row, cofactor of third row 1, it is plus. This row column is gone. 1 into minus 3 into 4 is 12, minus into minus plus, 2 5s are 10, that's equal to 2. Now similarly, the cofactor for 1, cofactor of 1, it is negative minus, this row and column is gone. 2 4s 8, minus 8, it is minus 8, minus 5 3s are 15, so that's equal to minus of minus 8 minus 15 is minus 23, minus into minus plus 23, and last element, cofactor of minus 2 is equal to, this row column is gone. 2 2s are 4, minus into minus plus 3 3s are 9, that's equal to 13. So 2, 23 and 13 are the cofactors for the last row. Now write down the cofactor matrix. So instead of writing the cofactor matrix, or we can write, therefore the cofactor matrix C is equal to cofactors. I just, instead of writing the adjoint, let me show how to write the cofactor matrix, then adjoint. In the previous problem, straight away we have written the adjoint. Here I will write the cofactors, then adjoint. The cofactors are 0, first row 0, 2 and 1. For the second row, minus 1, minus 9 and minus 5, and 2, 23 and 2, 23 and 13. This is the cofactor matrix. Now therefore, the adjoint of A is equal to C dash, the transpose of the matrix. The transpose of this is called the adjoint, that is 0, 2 1, first row becomes first column, minus 1 minus 9 minus 5, minus 1 minus 9 minus 5, and 2 23, 2 23 and 13. This is the adjoint. See, instead of writing the first row, second row, third row, if you put it in the form of a column, first column, second column, third column, straight away it will give the adjoint, right? Any method you can follow, either just find out the cofactor matrix and transpose it, or put the elements in first column, second column, third column, you will get the adjoint, that's it. Now therefore A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant is minus 1 into adjoint is 0 minus 1 2, 0 minus 1 2, 2 minus 9 23, 2 minus 9 23, 1 minus 5 13. Now since 1 by minus 1 is minus 1, just multiply each and every element by negative sign. 0 minus 2 minus 1 plus 1 plus 9 plus 5 minus 2 minus 23 and minus 11. This is the inverse. So therefore A inverse is equal to this much. Okay, so followed. Now what is the solution? Therefore the solution is x is equal to A inverse into B. What is x? X, y, z is equal to A inverse. 0 minus 2 minus 1, 1 9 5 minus 2 minus 23 and minus 13 into B. What is B? B is nothing but the constant matrix. 11 minus 5 minus 3. 11 minus 5 minus 3. Simplify this, that's all. Now same as usual, matrix multiplication, first row, first column. This is equal to 0 into 11 is 0, minus 1 5s are 5, minus into minus, plus 2 3s are 6. Second row, first column, 11 2s are 22, minus 22, minus 9 5s are 45, again minus into minus, plus 23 into 3 is 69. Again last row, last column, 1 11s are 11, minus 11, minus 5 5s are 25, minus into minus, plus 13 3s are 39. So that's equal to, simplify this, 6 minus 5 is 1. So what is minus 22 minus 45? Minus 45 minus 22 is equal to minus 69, plus 69 is equal to 2. It is plus 2, and that is 39 minus 39, minus 11 minus 25 is minus 36. That's equal to plus 3. This is 3. So therefore the value of x is equal to 1, y is equal to 2, and z is equal to 3. That's it. X is equal to 1, y is equal to 2, and z is equal to 3 is the required answer. This is how we are going to find A inverse as well as the solution for the given matrix. Hope you follow. So these are few problems for 5 markers in determinants. Matrices and determinants is very important chapter, right? Now let us take 3 mark questions in matrix. So this is a 3 marks question. Usually you may expect 1 question in 3 marks. Now to express this as a symmetric and a skew symmetric matrix, to prove that half of A plus A dash plus half of A minus A dash is equal to A. Now what is given? A is equal to 3 to 1 minus 1. Find out A dash is equal to 3 to 1 minus 1. Transpose of this. Now first find out P. P is equal to half of A plus A dash. Now that's equal to first half as it is A. What is A? A is 3 to 1 minus 1 plus A dash, that is 3, 1, 2 minus 1. So this is equal to half of, add this, 3 plus 3 is 6, 2 plus 1 is 3, again 1 plus 2 is 3, again minus 1 is minus 2. Now half of 6, 3, now this is equal to P, therefore let us call it as P is equal to half of 6, 3, 3 minus 2. Similarly on the other hand, find out Q. Q is equal to half of A minus A dash. Find out A minus A dash. What is A? 3, 2, 1 minus 1 and A dash 3 to 1 minus 1. This is equal to 3 minus 3 is 0, 2 minus 1 is 1, 1 minus 2 is minus 1, minus 1 plus 1, this is equal to 0. This is a skew symmetric. Right, skew symmetric, and previous one, this is the symmetric. Right. Now, what is Q? Q is equal to half of this, half of 0, 1, minus 1, 0. Now, to prove that, now take P plus Q. P plus Q. P is half of 6, 3, 3 minus 2 plus Q is half of 0, 1, minus 1, 0. Now, you can take 1 by 2 out, add this. 6 plus 0 is 6, 3 plus 1 is 4, 3 minus 1 is 2, minus 2 plus 0 is minus 2, divide by 2. So, 6 by 2 is 3, 4 by 2 is 2, 2 by 2 is 1, 2 by minus 2 is minus 1. What is this equal to? 3 to 1 minus 1 is nothing but the given matrix A. That's it. This is how we are going to verify this given matrix as a sum of a symmetric and a skew symmetric matrix. Hope you followed. Now that's all regarding this session. Let us meet with a different concept in the next session. Thank you very much.